Okay, so we're going to look at simplifying algebraic fractions, and the question that you see here is again taken from a past paper, and it includes the words simplify fully. Now that fully is a key word and holds an expectation with it, which is that both parts of this will simplify in some way or another. Now you might look at the bottom half of this and think, okay, not familiar with that, how does that work? It kind of looks like a quadratic, but it hasn't got a middle term, and that's known as the difference of two squares, which I will come to shortly. So the way to deal with algebraic fractions when you are just simplifying them is to look at the numerator and denominator separately. So let's look at the numerator first. It is a quadratic and requires factorisation. It has a leading coefficient, and there is a video on this on the channel, so if you're not sure about this, do have a look, but I'll just go through it quickly. We multiply the 6 by the number at the end and write the quadratic again. We then look at factors of 6, which will allow us to make, in this case, 1. There's a 1 which is unwritten at the beginning of that x. And they, of course, are 2 and 3, because 3 minus 2 is 1, and 3 times 2 is 6. Notice that the minus goes with the 2, it must do, it belongs to it. So we end up with 6x minus 2, having brought this 6x down into both brackets, and 6x plus 3. Now what we have to do before we are satisfied that this is the correct answer is to remove the factor of 6 that we introduced here with this multiplication. Now neither of those brackets on their own will divide by 6, but if we split the 6 into its constituent parts, 2 and 3, then we can divide this first bracket by 2 and this second bracket by 3, and doing that results in the contents of these two brackets here. Now that is the factorised version of the quadratic on the numerator. So we keep that, put it to one side, and then have a look at the denominator. And this is what I was mentioning to start off with, which is that the denominator is an example of the difference of two squares. It still needs to be factorised, but you can't do it in the conventional manner of factorising a quadratic. And factorising these is just simply knowing a fact, a mathematical fact. And if you have a look at my video on recognising and factorising the difference of two squares, hopefully it will become clear. But again, I've gone through this quite quickly for the sake of this particular question. 4x squared minus 1. Well, 4x squared has come from 2x times 2x, and 1 of course comes from 1 times 1, and both of those are squared, and it's a subtraction, so it's a difference of two squares. And what you'll find is that the difference of two squares will always factorise in a very particular way, which is that you get the square root of each term in the brackets, and one of them will be positive and the other negative. And that will never change, regardless of what these squares are. Have a look at the video for some examples. It will always factorise in this way. And so what we can now do is have a look at putting the numerator and the denominator back together, which gives us what's written in green here. So the numerator from the first part and the denominator from what I've just explained. And if you then have a look at the contents of those brackets, if they're identical, absolutely identical, then they will cancel each other out. So this one on the bottom and this one on the top, absolutely identical, and they do cancel each other out, which leaves us with 3x minus 1 from here and 2x minus 1 from here. Now that is simplified fully. If you didn't simplify the denominator, then you would not get the full marks for the question.